Okay, in this video I'm going to do an exponential decay problem, and what I'm going to do is I'm going to find the half-life of a substance. So in this case, remember the basic form of an exponential equation is a b to the t. We can equivalently write our base b as this value 1 plus r, where r represents the annual growth rate. Remember also that a represents the initial amount, t will be my variable, we'll let it stand for time. So in this problem it says, suppose we have some radioactive ion, the mysterious radioactive ion X, and we know that this decays at a constant annual rate of 4%. We want to know what the half-life of the substance is. And again, the half-life is the amount of time required for the substance to decay to half of its original size. Okay, that's what a half-life is. So I know the general form of my equation is going to be the initial amount. Well, in this case we don't have an initial amount given, we'll just call it r. Now the rate in this case is actually, it decays at a rate of 4%. So that means that our annual growth rate is actually negative 0.04. Okay, so this is going to be our annual growth rate in this case. The negative indicating that it's decreasing by 4%. Okay, so here I would just simplify this down, and we would get 0.96 raised to the t power. So basically this formula is going to tell us the amount of the substance that remains after t years, okay, since it has an annual rate. So we want to know the half-life. Let's just assume the initial amount of our radioactive ion X. Suppose our initial amount of this radioactive ion is just 100 grams. The half-life is going to be the same no matter what amount you start with. We could do it generically in terms of A, but I like to use numbers because they make more sense to poor Patrick. So now the problem that we're going to have to simply solve is, again, y is the amount after some time t. If we start with 100 grams, okay, so we still have our 0.96 raised to the t. Well, now if we want to have half of the original amount, well, half of 100 would simply be 50. Okay, so we start with an initial amount of 100, we end up with 50 grams. We want to know the time required to solve that.